the injection molding industry as DOE is a series of tests or experimental trials where inputs or factors are systematically adjusted to measure changes to the output results. There are 5 primary stages for conducting a designed experiment. These are planning, selecting the tests to run, conducting the experiment, analyzing the data, and then confirming the results. Let's review the steps and discuss the important questions and issues for each one. The first step is planning the experiment. This includes defining the objective, selecting the factors to be studied, and determining the settings or levels for each factor. In this phase, we also determine the response of interest. The response of interest is the variable we are trying to determine by running the experiment. We will refer to this simply as the response throughout these lessons. It is important to have a clear objective for the experiment. What do you need to learn? You may need to understand which of the key factors are affecting each response to decide the best setting for each factor, or determine whether other important interactions between inputs and outputs should be addressed. Timing of the experiment and budgetary considerations are also important factors to consider during the planning phase. The second step is selecting the series of tests to be performed. In this phase, we also need to determine the number of repeat samples for each experiment. In a designed experiment, a mathematical set of tests, referred to as orthogonal array, OA, are used for this step. We will need to determine the factors that need to be studied. If there are multiple responses, which is common in injection molding, we need to determine the best factor settings to simultaneously target or optimize the different responses. Factors to be studied include melt and mold temperature ranges, the most appropriate fill time, pack pressure and optimizing the times for the packing phase and the gate sealing, overall remain cooling time, and cycle time. The third step is conducting the experiment. It is important to have a written plan or protocol in place, and that someone from the team is present while the trials are being conducted to note any deviations from the experiment protocol. After conducting the experiment, the fourth step is to measure the responses of interest and analyze the results. In this stage, you will utilize the graphs and charts along with the statistical output generated from the software used for the experiment. The fifth and final step is the confirmation phase. By making a prediction of the best setting for each factor and then trying this setting one or more times, you can confirm the results. Verifying the optimized process setup is essential for maintaining part quality.